Let's talk about how we can apply the distance formula to other concepts. As a refresher, this is the distance formula. It calculates the length of a segment that's been graphed in the coordinate plane. x1 and y1 are the coordinates of one of the endpoints, and x2 and y2 are the coordinates of the other endpoint. Plug each of those four numbers into this formula and simplify, and that tells you the length of segment AB. But let's apply this to the segment addition postulate. You might remember that from the second lesson that we learned this year. It tells us that AB plus BC equals AC. We can actually use the distance formula to prove why that's true. In order to use the distance formula, we'll of course have to know the coordinates of each of these 3 points, so let's write those down real quick. A is the point -7, -3, B is the point 1, 3, and C is the point 5, 6. So what we're going to do is calculate 3 lengths. We're going to calculate the length of AB, and the length of BC, and we'll calculate the length of AC, the entire segment. And then at the end we'll show that if I add AB and BC, it's going to be the same length as AC. So let's do it. To find the length of AB, we're going to use these 2 points. I'll plug them into my formula like so, and simplify, and I find out that AB is 10 units long. Again, these 3 steps of simplification, you don't have to show me those 3 steps. If you'd rather just write the distance formula and then plug this whole thing into your calculator, you're welcome to do so. Now let's find the length of BC. Plugging in our numbers from x2, y2, and x3, y3. I know that's a little weird this time. We have 3 different points that we're working with, so you can just think about each of the x3s being x1s in the formula, or just subtract your x's and subtract your y's. It really doesn't matter what your subscripts are, as long as you're consistent with how you fill in your formula. Then we'll simplify, and I find out that BC is 5 units long. The last thing we need to calculate is the length of AC, so I'll be using x1, y1, and x3, y3. Which will look like this. Then I'll simplify, and I get that AC is 15 units long. The last thing I need to do in order to actually prove that the segment addition postulate works is plug each of these answers into the segment addition postulate and verify. So here we go. AB is 10, BC is 5, and AC is 15. And is 10 plus 5 equal to 15? Yep, it sure is. So we have successfully proven the segment addition postulate using the distance formula. We can also apply the distance formula to calculating perimeter. In order to calculate the perimeter of any shape, you need to figure out the lengths of all of its sides and add them all together. 2 of the sides of this shape are actually pretty easy to figure out because they're horizontal, and you don't have to use the distance formula to count the length of a horizontal or vertical segment. You can just count. For example, RA is 6 units long because the distance from R to A is 1, 2, 3, 4, 5, 6. Easy peasy. And TP we can calculate in a similar manner. Because it's horizontal, you can just count. It turns out to be 18 units long. However, the length of TR and the length of AP, those ones I have to calculate using the distance formula. You can't just count diagonal segments. You have to use the formula for that. Let's start with the length of TR. I'll plug each of those points into my formula and simplify. However, I get the square root of 153, which is not a perfect square. So we need to make a factor tree to simplify this radical, because the instructions tell us that we actually are supposed to express our answer in 2 ways, one as a simplified radical and one as a decimal rounded to the nearest hundredth. So I need both of those simplifications for the length of TR. Well, 153, that breaks into 3 and 51. 51 breaks into 3 and 17. I'll go ahead and cross 51 off because I broke it down. 3, 3, and 17 are all prime numbers, so I know I've reached the ends of my branches. Now I'm ready to look for pairs of numbers. I see a pair of 3s, and I see a lonely 17. So that tells me that I can simplify the length of TR to be 3 root 17 units. Or if you just type the square root of 153 into the calculator, it'll give you a decimal approximation of about 12.37 units. We now know 3 of our 4 sides. Let's calculate the 4th one. The length of AP would be equal to this by plugging in each of my x1s and y2s and then simplifying. I get the square root of 225, which is a perfect square, That means that the length of AP is exactly 15 units. Well, to figure out the entire perimeter, I need to add all of my answers together. And I'm going to do that in two ways because TR is expressed in two different ways. I'm going to have one answer for my exact radical and one answer for my decimal approximation. The exact perimeter would be adding up all of the integer answers, the 15, the 6, and the 18, and the radical, 3 root 17. Now when you add them together, the integers can be combined. Those are like terms. That's how I got 39. But the 3 root 17 is not a like term with the other ones because it has a radical, therefore you just have to leave it separate. So the exact answer for the perimeter of this trapezoid is 39 plus 3 root 17 units. I know that's a mouthful, but it is exact, which in some cases is more important. Some cases, however, you just want an approximation. In that situation, you can add the 15 and the 6 and the 18 and the 12.37. Since none of these are radicals, you can add them all together and get a total approximate length of 51.37 units. And the last thing that we'll apply the distance formula to is just a quick word problem about Captain Geometry the pirate again. He's going on a hike from the waterfall at -5, -6 to the treasure, which we located in the previous lesson about midpoints, which is at the point 90. So if 1 unit on this coordinate plane is equal to half of a mile, how far is he going to have to hike? Well, we need to calculate the length from W to T, from -5, -6 to 90. So I'll plug those numbers into my formula and simplify, and I get 232 square rooted, which is not a perfect square. So if you're simplifying it to a exact radical answer, it would be 2 root 58. But this wants us to just round to the nearest tenth. It doesn't say anything about needing an exact simplified radical form. So I'm going to go ahead and convert that to 15.2 units. But that's not actually my answer, right? Because it wants to know how many miles is he going to need to hike, not how many units. And it says that 1 unit is equal to half of a mile. So to get to my answer, I'll need to multiply 15.2 units by a half, or 0.5. Therefore, it turns out that Captain Geometry will have to hike 7.6 miles to get to the treasure. And that's all you need to know about the distance formula, and that actually wraps up Unit 1. After this, we're moving on to a unit on logic and reasoning and proof.